Before getting into topics such as advanced modeling and causal MMM, let us first go through a list of frequently asked questions about MMM. Question 1. How much data is needed for building MMM models? The honest answer to this is it depends. MMM definitely needs historical data that is aggregated either daily or weekly. Lifesight prefers working with last 2 years of data. In certain cases, having 3 years of data could be better. There are a few very important trade-offs to consider while deciding the right data lookback. The first trade-off is to decide between inference and prediction. If the primary focus of a MMM project is to infer the recent incremental contribution from all the covariates under consideration, the recent 1 year of data alone could suffice. The downsides of including just 1 year of data is that we would end up underrepresenting the influence of certain temporal factors such as seasonality and trend in the baseline, and we will also have limited forecasting accuracy from such models. A very important point to note here is that MMM is primarily a system for inference. MMM generated insights will have to be applied on top of other forecasting techniques to support forecasting use cases. If you only want MMM as a backward-looking inference tool, 1 year of data is probably enough. But if you want to use the model for planning, predicting, and forecasting, at least 2 years of data is recommended. Trade-off number 2. From a historical data lookback perspective, more data is not always better. MMM measures the average state of the independent variables based on the data at hand. Though it's possible to filter decomposed data for different time periods, insights for these time periods tend to get pulled in the direction of the average. This is also known as regression to mediocrity. So if we use 3 years of data, where your first year could be quite different from that of the recent years, as all the years have equal say on the model insights, coefficients of the recent years could get pulled in the direction of earlier years. Trade-off number 3. More variables demand more data. Regression-based MMM tends to overfit if we have too many covariates trying to explain the dependent variable. This is something you need to be wary of as a modeler or even as a consumer of MMM models from third-party vendors. The standard industry practice to address this issue is to run models at different levels. For example, at level 1, we could run the model with only paid variables as covariates explaining the target variable. This will quantify the baseline against the paid media, and then we could iterate this process by running other regression models with other control variables explaining the decomposed baseline variable of the previous iteration as the target variable. At Lifesight, we address this in a very unique way using structural causal modeling. Structural causal models are fundamentally different from regression-based approaches and do not have to deal with overfitting problems the way regression models do. Also, we are creating a video to specifically explain how structural causal modeling works. That brings us to frequently asked question number 2. How is MMM fundamentally different from user journey or exposure-based attribution? MMM is a way of making inferences on top of aggregated observational data. This approach is privacy safe and quasi-causal. Here, we are not worried about user-level touchpoints and paths to purchase or conversion. Models look at marketing initiatives across dimensions such as geography, product category, device types, and so on as temporal activities and leverage intervariable variations to make inference about how they drive outcomes of interest. MMM is an incrementality system, unlike attribution. When we spoke about incrementality in an earlier video, a link of which could be found in the description of this one, we took the example of eBay, where touch-based attribution was overcrediting bottom of the funnel. MMM as an approach is immune to such fallacies, provided the nature of causal structure of interactions between top of the funnel spend and the bottom of the funnel spend, which are by the way called as mediator variables in the context of structural causal models, are properly incorporated into the model. MMM talks in terms of incremental contribution and not in terms of allocating or distributing credits to touch points the way attribution does. Question number 3. How do we trust MMM? Let us discuss model accuracy. Accuracy is a very important concept in any machine learning project. Technically, it refers to the degree to which a model's prediction align with the actual values in a dataset. But it's a metric that could easily be gained. Let us take this example. In a population, 1% of the people have a deadly disease. You build a ML algorithm to predict if a particular person has the disease given certain descriptive characteristics of the person, such as gender, habits, height or weight, and so on. Now, to get 99% accuracy for this algorithm, all you need to do is to always say that the person is healthy regardless of the input variables. This way, you are guaranteed to be 99% accurate on average, as 99% of the people do not have this disease. Similarly, high accuracy could also be obtained by memorizing instead of learning from historical data. To overcome these accuracy pitfalls, data scientists look at certain other metrics such as precision, sensitivity, and effort score. This example is for a classification type problem in ML. MMM is a regression problem. However, this example was specifically taken to emphasize the need to approach the question of accuracy by evaluating multiple goodness of fit metrics. When it comes to MMM accuracy, we typically look at these metrics: R-square, MAPE or mean absolute percentage error, and NRMSE or normalized root mean square error. All of these metrics should be evaluated for both the training and testing data. All of these are descriptive or backward-looking accuracy metrics. Essentially, based on how closely you have been able to estimate historical data, they are all susceptible to overfitting problems. At Lifesight, besides these descriptive goodness of fit metrics, we also follow 2 additional practices. They are holdout testing and short-term forecasting. Holdout testing. We keep a part of the data outside of the modeling scope. Depending on historical data availability, this could range between 4 4 to 12 weeks. We apply the model trained on the training data to predict on this holdout data and report estimation error for different windows of holdout period. Essentially, giving the marketer an understanding of how much the model has truly generalized on the holdout data based on the observational or training data available. Number 2, short-term forecasting. We use short-term forecasting as a better proxy for model's accuracy. If the model can predict 1 to 2 months of revenue conditioned on your paid media variables and other control variables, that's a good indicator that the model has truly generalized on your data within an acceptable range of error margin and that it has its utility as a tool to predict and plan. That brings us to question number 4. What is a better approach to MMM, Frequentist or Bayesian? Before discussing this, let us first try to find out if you are fundamentally a Bayesian or a Frequentist. Try answering this question. Say I have a coin in my hand, and if I toss this coin, what's the probability that it gets tails? Take a few seconds if you want. If your answer was 50%, you are a Bayesian. You had a belief that fair coins will give tails or heads in equal probability. I have asked this question to at least 20 people in the recent few days. All of them, all 100% of them said 50%, though none of them asked the clarifying question of whether the coin was fair to start with. They had a belief even in the fairness of the coin. For a Frequentist to answer the same question, he or she would first need to toss the coin a few times, say 10 times. Now let us say we toss this coin 10 times and it gives 8 tails and 2 heads. Now for a Frequentist, probability of tails is 8 on 10 or 80%, and for a Bayesian, probability of tails now stands at 75%. Note that this Bayesian started with a wrong uniform prior of 50% or 0.5 and now stands close to the possible truth that the coin is actually not fair, and in every iteration, this posterior moves closer to the possible truth of 0.8. Let us say we repeat this exercise 10,000 times and we get 6,500 tails. At this point, both Frequentist and the Bayesian, who started with the wrong prior, will estimate the actual probability of tails as 0.65. So the conclusion, given enough data, it doesn't matter if you are a Frequentist or a Bayesian. Your estimates will converge to a single answer. This is, however, a simplified view of the Bayesian-Frequentist dichotomy. These are fundamentally two philosophical worldviews, and there is a lot of academic merit in this debate. Now coming back to the world of MMM, there are some unique challenges at play here. MMM is a small data problem. That is, MMM does not have enough data to get your Bayesian or Frequentist model to converge to the ultimate truth the way it worked out in our coin tossing experiment. However, regardless of the approach, you can get similar models from both Frequentist and Bayesian approaches. Just to take one example, with everything remaining the same, if you build a Bayesian model where the priors of paid media variables is decided in accordance with the quantum of spend in those variables, and if we also build a Frequentist model where we try to optimize for something like a decomposed RSSD, you will get similar, not same, but similar and closer estimates from these models. That is, with all the other assumptions being similar as well. While both Frequentist and Bayesian MMMs have their own unique advantages and disadvantages, it's very important to complement MMM with more causally accurate measurement systems wherever necessary and possible. Earlier, while discussing causality, we referred to decision-driven analytics and how runners or business decision makers should take control of the decision-making process. Later, when we discuss causal MMM, we will get back to this point. It's very important to incorporate business-provided wisdom to the modeling process in terms of causal DAG, assumptions around transformations, assumptions around baseline factors, among others. Question number 5. Why should we go with an MMM vendor when there are free MMM libraries available? To this question, we like to always take this example. Most of the tech stack today are built on top of open source libraries with very strong developer community support. Backend is built on Node.js or Python, frontend on React or Angular and its many variations. Most of the data scientists use openly available libraries for regression, classification, causal inference. All of this doesn't mean that one can build scalable web applications or data-intensive applications without expert backend and or front-end engineers or without strong data scientists. We recommend everyone to get their hands dirty on MMM libraries. MMM is a very complex process. To get a model that's robust and accurate, one needs to go beyond the standard ML practices. MMM needs to interact with quasi-causal mechanisms of inference, causal tools such as geotests for calibration, forecasting techniques such as ARIMA, SARIMA, and so on for better planning. Getting the model right is just one part of the entire MMM lifecycle. It's also important to watch out for model drifts through a suite of algorithms referred to as post-deployment data science. All of this put together constitutes a very complex and non-trivial multi-stage process from getting your first model built to keeping it accountable and actionable. In a later video, we will discuss everything to watch out for and demand from your MMM models and from your MMM vendor. MMM is also not a one-time project. It's an iterative process with some pre-modeling, modeling, and post-modeling stages. We will also make a video on the different stages in the life cycle of a causal MMM. So these were some of the frequently asked questions about MMM. If you have any more questions, reach out to Lifesight by filling the form in the link provided in the video description, and we'll be more than happy to help you get your questions answered. Next, we will talk about advanced modeling processes, and we will do this from the perspective of causal MMM.